Fill in the bubble that is most appropriate. So, we had the repeating, right, for the first one. 4/5, the most general is fraction, right?
Yep. Whole number.
Okay? Not whole number. Whole numbers have no fractions in them. Okay, oh, the next one. Next one, yes. Whole number, fraction, negative,
Oh.
repeating decimal, but it's not an integer, right? It's negative, but it's not, okay?
It's repeating.
Terminate, oh, should be the next one down, right?
Yeah.
Thank you. Okay. 17 should be terminate. Should be terminate again. Should be integer. Fraction. Now, every single one of these categories is a what from yesterday? What kind of numbers? Every single one from 12 to 21. All of them are rational. All of them are rational. Every single one of these on this page is a rational number. Okay? Now, you also had to do over here where you were telling me and giving me an example of 2 terminating, 2 whole, 2 repeating, 2 integers. And then it says, what is a rational number? Okay? If you did not answer that, you want to make sure you do that. Okay? Think about what we did yesterday when we did this classifying up on the board, right? Remember? All of these weren't. And you can look back at your notes from yesterday to make sure you answer that question. Okay? So, yesterday, this should be part of your definition, right? Any number that can be written as a fraction. What else might I want to add to that? I might want to add that it is also a decimal that what? Repeats or ends. When you write that definition, this would be the key things. Any number that can be written as a fraction, a decimal that repeats or ends. Terminates. We'll use, since that's what they use in there. Terminates. Okay? Here, never, never, never repeats, right? Never ends. Never repeats, never terminates. Okay? So, keeping in mind the difference in those. This was your pi. Remember when we had that example of pi divided by pi, we said that is actually a rational number because that's 1, right? So thinking about all those different ones, right? All right, so these were your categories that we looked at. And today as we go to your notes, we're going to skip this page. In your notes, I want you to go to this page. And we need to do some reading first. Someone want to volunteer and be my reader? So, Robert, go ahead and start for us since you're volunteering people. So you're going to start on the, repeating decimals, reading that.
Repeating decimals don't have a last place value. Use when changing them to a fraction. Instead, you must use the equation. Here's how to change a repeating decimal to a fraction.
So first, you're going to write 0.48 and put an x equals that, but you're going to write it out this way. So the first thing we're going to do as we start our problems is we're going to notice how many numbers repeat. If 2 repeat, you're going to write that like that. X equals 0.4848, and usually after this you can stop. Okay? It says we notice, since there's 2 numbers repeating, that if we take it times 10 to the second or 100, because there's 2 digits that repeat, we are going to multiply both sides here by 100. Now if I take 1x and I multiply that by 100, what do I get? 100x. If I multiply a decimal by 100, what happens to that decimal? How many places should I be moving my decimal over when I multiply by 100, Jeremy? I should move it 2 places. So I'm going to take this side times 100, right? That gave me 100x. And I'm going to take this side times 100. And when I multiply this side times 100, we move it over 2 places, and I now have this number. 48.484848, right? Keeps going. It says the next step, subtract the x from the 100x. So when we do our homework, you're probably going to need a sheet of notebook paper, and if you don't have one, I'll have some for you. What you're going to do is you're going to start. So this will be our question. It'll start like with letter A or we'll say number 1. And it will say convert 0.48 repeating. This is where you're going to put your answer, right? So you're going to keep this box. Then you're going to put down 1x equals and 100x. Our next step is to do what they said here, okay? So then you're going to put this on your paper. 100x minus 1x, right? 100 minus 1 is 99. 48.4848. Look at how beautiful this is. What happens to all these decimals back here? They cancel off, right? When you take 0.48 minus 0.4, all those cancel. So I'm left with 99x equals 48. Pretty nice right now. I need to know what x equals. So it's 99 times x. Last year you guys solved equations. We are dividing both sides by 99. And I'm going to be okay if you stop at this point. Because this is my year of giving up that it has to be in simplest form. So it's your lucky year. Yeah, last year I was on them. And I'm like, you got to simplify. It's your lucky year. Okay? So let's do this one together. And then we're going to hopefully get you started in your homework so that you can get practicing these in class. Okay? So if we are looking at this one, this is our problem. We are going to start with x equals, you want to put all that underneath your desk so I don't trip and fall and embarrass myself. That would not be good, right? Mr. Graveling. Okay, so we're going to put down x equals, everyone, right below. 0.207, what? 207. Should we write another 207? You could, or you can put the dots. What should I multiply by? Because there's 3 things that repeat. 100 or 1,000? 1,000. So put right below this a parenthesis with 1,000. Over on this side, put 1,000. So here we're going to have 1,000x, right? What does 1,000x equal? That means move the decimal over 1, 2, 3 places. It equals 207.207, right? Everyone in agreement. Everyone have this on your paper. Check that your shoulder partner has this written down. You do not have to do anything with hers. You just got to make sure everyone has this, okay? Good job. Now we're going to do the subtraction part, okay? Now we're going to do subtraction. So we're going to start with our 1,000x, right? 1,000x equals, we said that equaled 207.207. Right below it, we are subtracting this x, which we're going to write as 1x. That was equal to 0.207. Oh, it's just so beautiful, isn't it, on a Friday? Yeah. 207, all of those cancel, equals 999x, right? 1,000 minus 1, 999. Good job, dude. Okay?
Thank you.
Now, I have 999 times x. What do I have to do to simplify? To get x by itself, because remember, I want to find 1x. I am dividing both sides by 999. 207 divided by 999. Now, I don't know if you know division rules. When you guys did your multiples, like if we're trying to show if something divides, 7 plus 2 is what?
7 plus 2 is 8. 9.
9, which means I can divide both of these by 3. Okay? So, guys, quit. So 999 divided by 3, that gives me what? 333. 207 divided by 3. 3 goes into 20 how many times? 6, right? That's 18. So I'm going 3 divides into 207. 3 goes in there 6 times, right? That was 18. 20 minus 18 gives us 27. I'm going to take this answer, or I will take this answer. So we are going to start on the top of the next page. Ooh, what if you got a weird one like this? Okay? You have a weird one like this one. Next page down for you guys, right?
Yeah.
Okay? It says, if you have 0.23 to a fraction, notice, only the 3 is repeating. They're going to show you one way of doing this. I'm going to show you a different way. I like my way better than how they do it up here, but you can choose either way. What?
Oh, what should I do here? I'll go down the wrong one.
Just put an arrow, I don't know, put 207 and put this problem up above, I don't know. So, as we take a look, first thing we are going to do, we are going to write x equals 1.025, and then it's 555, right? Now, when we do this one, it says one number repeats, right? So we should multiply by 1 repeats. Multiply by 10. So put a times 10 on both sides. 10x equals, I'm only moving it over one place, right? 1.0255. Oh, it would be 10, thank you. Yeah, see, it's good you guys were on. See, we all make mistakes just like that. And you're getting ready for lunch, aren't you? We're going to subtract when we come back.
On my knee. Not good. Yeah.
What? Alright, so, here we are. We're subtracting, right? We are going to put, quiet, 10x. What was 10x equal to? 10.2. And I think if you put at least that many 5s, so about 4 of them, you should be good. The second one down that you are writing down is 1x, and this is what we're subtracting, equals, you're subtracting 1.02. This isn't as nice, right? But you can still do the subtraction. Do you see how this isn't as nice? Okay. So, 10 minus 1, 10x minus 1x still is leaving us with 9x. Agree?
I agree.
Okay. When we subtract our decimals, you definitely wanted these decimal points lined up, right? So I subtract from the back. These 5s are canceling, but when I get 5 minus 2, that is 3. 2 minus 0 is 2. And 10 minus 1 gives me
9.
9.
Good job, Steven.
I am dividing both sides, quiet please, by 9. And x equals, and mathematically, we cannot leave our answer like this. Because fractions really cannot have decimals in them in order for it to be a fraction. So, if we are looking at this, I need to move the decimal point over 2 places. And here the decimal is right behind the 9, right? Here's the decimal here. So this is really like 9. If we wanted to add 2 places, we could have 9.00 and 9.23. To move the decimal place over 2 places, if we look up above what it's in that directions up here, right? It says you need to now either multiply by 10, 100, or 1,000 to get rid of the decimal in our fraction. We want to move it 2 places. We are going to multiply both numerator and denominator by 100 because we want to move it 2 places. In this problem, they multiply by 10 because they only wanted to move it 1 place. We end up with 923 over 900. Now, someone has asked me, okay, so if I want writing this as a fraction, can I change it to a mixed number? 900 goes into 923 how many times? Equals 1, right? 1 time is 900. 1, and what do I have left? 23 over 900. Okay? I would take either one of these answers, but when you finish your homework question and you've done all this work, you want to make sure you go back here and either put 923 over 900, or you write it as 1 and 23 900s, right? You want to put the answer for me. And it says, why are repeating decimals, why are they rational? The key reason why they are rational is because we can write them as a fraction, right? That's our key thing. Rational is a fraction, as long as 0 is not in the denominator. Rational means fraction, okay? So, turn to that next page in your notes. Okay. You know some of these already, okay? You know some of these. I want you to try and just take a couple of minutes and go as fast as you can. And it says, I'll give you 5 minutes. I don't know if I'll give you quite 5. Do all the ones you can, so you can skip around, right? So we know 1/2 is 0.5. And 2 over 2 is 1, okay? The next row, if you know your thirds, put them down, right? If it's a repeating one, go. 1/5 is 2/10, so 0.2, right? 2/5 is 4/10, 0.4. 3/5 is 6/10, 0.6. 4/5 is 8/10, 0.8, right? Notice I put in my halves. 7ths are tougher. 8ths. Oh, 2 8ths, that's 1/4. That's 0.25, right? 6 8ths is 0.75, same as 3/4, right? Does anyone know 1/8? 0.125. So take out your calculator and let's do some of these. How about 1/6? Could we do 2/6? 2/6, we should do that. That's the same as up here, 1/3, right? 0.3 repeating. 4/6, that's 0.6 repeating. Okay, when I put it on my calculator. So use your calculator and let's get a few others. Raise your hand if you have 1/6 for me. Point what? 0. What do you got, Jeremy?
1, 6.
And then the 6 repeats. Okay. So we need 5/6. Anyone have 5/6? Raise your hand if you got that one. Use your calculator by all means. 5 divided by 6. Hit the division. 5 divided 6 equal 0.83 repeating. Okay? So when you have these fractions on your calculators, the 1/7, these get really long, and they actually, we need to write down, if I'm looking at 1/7, I want to go back 6 places. So, everyone have 1/7 for me. Okay, 0.142857. Okay, the next one, if we are looking at that as we keep going across. Okay, so fill in, do the last row with your calculator. And if you don't have a calculator, check with your shoulder partner. And like 3/8 is 0.375, and you could think of adding 0.125 to each number. So 0.5 plus 0.125, that's what 1/8 is, that's 0.625. This is 0.875. 1/9. What are we, do your 9ths. If you haven't done the 7ths, do the 9ths. And then once you do a couple of them, see if you think there's a pattern for me. Do the 9ths right now. Do 1 divided by 9, 2 divided by 9, 3 divided by 9. 3 divided by 9, we already know that one. Right? That's the same as up here, right? So 3 divided by 9, that's 1/3. That's the same as here. That's the same as up here, right? This is our 0.3 repeating. Do we know 6/9 already too?
0.6
0.6 repeating. That's our 4, 6, right? So do you see how some of these you really don't need your calculator for? 0.6 repeating. Did we start seeing a pattern here? 1/9 is what? 0.1 repeating. 0.2 repeating. 0.3. Do I have to do the rest? Put them in my calculator. 0.5 repeating. 0.7 repeating. 0.8 repeating. Shouldn't this be 0.9 repeating then? Okay, so they talk about that in your notes a little. I don't know if we're going to watch that video today. Okay? The sevenths. The reason I didn't put the sevenths in is I want you to look. Here's what the sevenths are. This is 1/7. This is 2/7. This is 3/7. So what happens, and I don't need you to, but patterns in math come up a lot. I don't need you to know these and memorize this. But if you are looking at 1/7, 1/7 is equal to going around this circle. These repeat. 1/7 is a repeating decimal. It is equal to 0.14287 repeating. And 2/7, you're going to start with the next biggest number going around this circle, or this hexagon. So 2/7 is 0 point, and we're going to start at 2, because 2 is the next biggest number, right? And it's 285,714. And then it would come up again. Now our calculator usually doesn't show much more than that. So if I was doing 3/7, the next one after 2, next biggest one is? The 4, good, thank you. I was going to go with 5. 0.42857, right? And then 4/7. It's just kind of a cool pattern thing. You don't need to know these. You don't have to memorize them, okay? But the key thing you need to know is if the decimal repeats or ends, it is what kind of number, everybody? Rational. If the decimal repeats or ends, it is what? No! If it repeats or ends, it is? Rational. If it repeats or ends, it is?
Rational.
If a decimal repeats or ends, it's what?
Rational.
Thank you, thank you. Mr. Radlin should be able to hear you, but, okay? So if you notice this pattern, 0.111, 0.222, that pattern for our ninths, right? But then we said 9/9 was equal to 1. But if we are continuing that pattern, shouldn't 9/9 be equal to 0.9 repeating? Right? And when you think about this, the reason that 0.9 repeating, and I'm not going to show, there's a video that goes with this, but if we think of doing our rule that we just did, right? X equals, so let's start it off and put X equals 0.999, right? So in your notes, do you see where this is? It's on the bottom of 5 notes. What do I have to move? What do I need to multiply by? Because one number repeats. So 10x. We're going to multiply both sides by 10. Multiplying here by 10, we end up with 9.9. What did we say we're going to do? We're going to do subtraction, right? So to do subtraction, we're going to take the 10x minus 1x. That gives me 9x. On the other side of that, this was 9.999. 0 minus. So 9x equals 9, because those are canceling, right? And 9 over 9 is 1. And if you think of that 0.9 repeating, like if it keeps going 999 all that way, it is so close to 1. And when you get into your upper level math classes, you're going to see some of those. Now, I want you to take a look at 1 and 2 in your homework in your workbook on A5. Do you really have to do 1 or 2? do you know from that table we just did? Okay, now if you need to do it, you would, right? So, 1 and 2, do you have to show any work for it? Okay, you should know those. You can look back at your notes at that table, right? Does that make sense? Number 3, 4, 5, 6. Cross off. Let's see, where are the last ones here? Yeah. Cross off number 11. And cross off number 12. How ugly are those ones? Okay. Yeah.
Number 3, if you already know it or like on the table, we have to work.
For number 3. Wait, yours looks a little different than mine up here, doesn't it? No, it doesn't. Wait.
No, it doesn't see them.
So you have.
Steven.
I think I might know. Is this what your number 1 looks like?
Yeah.
Okay, so your 1, 2, no, we're gonna do 3, because 3 is not one you have. And 4 and 5. But we are gonna cross off. Okay, so what else do you have to do besides this page is back at the beginning of our lesson on here. We need to do now number 2 and number 3 and I think just 2 and 3. Okay? Just 2 and 3 back on that one. So, should we do 2 and 3 first and then you can do the rest of A5? Let's at least do 2 together. Okay? Number 2. We are going to start with, this is where our answer is going to be, right? So this is where you're placing your answer. Okay, does that make sense? You want to box that. Some of you, when we did that approximating square root, you never told me your answer, right? So from the page before, and if you, by the way, did that and you needed to show it to me, I'd love to see it. So we start off with x equals. What does our x equal? 0.484848, right? What do I need to multiply by to get? Move it 2 places because I have 2 numbers repeating. To multiply by 100. So I'm going to put 100x, right? Equals, moving my decimal over 2 places, I now get 48.4848. I have to subtract them. 100x equal 48.4848, right? Oh, some of you aren't doing this with me, then you get to do it on your own. Number 2, right here. I'm trying to help you out. 2 and 3 need to be done. This is the work I need to show. We're going to subtract 1x, which is 0.4848. 100 minus 1 gives us 99x. Oh, those 4 8s, that's beautiful. They cancel. 99x equals 48. We're going to divide both sides by 99. The answer you're going to put up here is 48 divided by 99. Now, some of you have your calculator. Put it in your calculator. 48 divided by 99. 0.48, repeating. That's how you can check it with your calculator, right? You put in 48 divided by 99 and you should get this. And if it doesn't work, you did it wrong, right? You got to go back and find where you subtract from. So do number 3. When you finish number 3, you are then going to we already said we're taking care of 1 and 2, then you're going to go on to 3, okay, and keep doing those. Number 4 and 3 are kind of like what we just did. These are multiplied by 1,000, right? Multiplied by 100, okay? When I start number 7, I'm going to start it with a x equals. And then I'm going to go 10x. And then you're going to do your subtraction, right?
Yeah. Yep.
You may only use 3 over 5.